100% ionization. A strong acid or a strong base, we have learned in the past that they will completely dissolve, 100%. We symbolize that with an arrow. However, a weak acid or a weak base, it's not going to ionize 100%. Only some of it will. And so, whenever we have a weak acid or a weak base, a certain percentage of it is going to form ions. Now here it says example 1, you have 0.225 solution, molar solution of a weak acid. We don't know what this weak acid is, so we could symbolize that with HA. The A stands for acid, and then an acid has a hydrogen. And it says that 2.7% of that is ionized. Calculate the H plus and A minus concentration. So in order to solve this, we need to write our equation. We always start off with our equation. So we're going to write HA. It dissolves to form H plus and A minus. And it says that we're starting off with 0.225 molar solution of weak acid, and we don't have any of this at the beginning, right? But what it does say is that we're going to end up ionizing a certain percentage of this. So if you multiply 0.225 molar solution by this in the form of a decimal, it's going to tell you how much is going to dissolve, how much of it is going to be in its ion form. And we have 0.0608 molar solution. So that's gonna be this right here. That's gonna be X, right? Because that's what we're gonna have here. And if X is equal to this, then that means this is gonna be the same. And then here, if you subtract 0.225, our original, minus the amount that dissolves, we can figure out how much of this remains in solution. So that's how much acid remains after some of it got dissolved. And so you put 0.225 minus X, which is this, in your calculator, you're going to get 0.219. I recommend you do this for every problem and then you start answering the questions. So, for example, here it says calculate H plus and A minus concentration. It's right here. H plus concentration is right here. So it's 0.0608. And it's the same. It's going to be the same for A minus. Okay, so that answers that part. Part C says calculate the undissociated HA. So the amount that did not get dissolved. So originally we had 0.025, but then some of it dissolved. So we have to remove that, and we ended up getting this. So HA, original acid, dissolves a little bit, and we have this much that remains undissociated. Okay, so that would be that. That would be the answer for that. And then it says calculate OH. So this is not OH. Okay, so don't get confused. This is not OH. We have to figure out the base concentration using the H plus. Okay, so if we have the H plus, we've learned in the past that we can use the auto-ionization equation to solve for one of these two. So we have H, it's right here, 0.0608, and OH, 1.00 times 10 to the negative 14. OH is going to equal 1.65 times 10 to the negative 12. Okay, so that is the concentration of OH. And then how do you find the pH and pOH? We learned that the last lesson. So if you were to take the negative log of this, then that's going to give you the pH. So when you do that, see if you can do it in your calculator, you should get a pH of 2.22. Then you could take the negative log of this. You could also find your pOH, or you could just subtract by 14. So pOH minus is equal to 14 minus 2.22. You could do it either way, and you'll still get the same answer. So that is that. And then the last question, I believe, is just asking for Ka, which is pretty easy. You literally just use these answers right here at equilibrium, right? So you're going to use these numbers where Ka is equal to the concentration of this times the concentration of that, or you could just square it, divided by 0.219, and that'll give you your Ka value. So I'm going to write it down for you, and that's going to give us 1.68 times 10 to the negative 4. And it makes sense that it's smaller than 1 because weak acids partially dissolve, so it's going to remain mostly in this form, in its molecular form, and very little will be found in its ionized form. You have a base this time, so we're not going to use HA anymore, we're going to use a B. The base can be symbolized in its generic form with a B. So a B will represent base. Remember, bases accept hydrogen, and they also form OH minus. Okay, so this would be the generic equation for a base. It says that you have, originally you have 0.311 molar solution of weak base. So that means that's going to go here. And that's all we dump in solution in water. And then equilibrium is going to happen. You know, there's going to be some dissolving. And so we're going to subtract x, add x, add x. And usually we're given one of these numbers down here. And we're given H+, but we're not given OH, so you have to think, how do I convert this into OH concentration so that we can put it right here? And you guys learned already that you can interconvert between H+ and OH using the auto-ionization equation. Okay, so the auto-ionization equation, and when you plug in 8.18 times 10 to the negative 3 in here, OH is going to equal 0.0122. Okay, so that goes here. So that means the at is X. So that means that concentration is the same for this guy right here. And then if you subtract that from that, then you'll get the original amount of base. Not the original, the base that remained in its molecular form that did not dissolve. And if you do that, you'll get 0.29. Okay, so now we're going to start answering the questions as calculate OH minus, and we did that using this equation. It says calculate the concentration of unionized base molecules. So this is the original amount, but after it dissolves, we have to subtract the amount that ended up being dissolved, and that will give us this answer, which is the concentration of unionized base. So that would be your answer to this one. And then KB. KB is a simple calculation. It's products over reactants, so 0.0122 squared, right? Because there's two of them, one there and one there, over 0.29. And that's going to give us 4.98 times 10 to the negative. Okay. What percentage of base is going to dissolve? So what we do is we put, it's usually a small number over a big number, so you just pick one of the two. So I'm going to pick 0.0122 because that's one of our ions that forms. So I'm going to put 0% ionization. Percent ionization is equal to 0.0122 over total. Your total. You have to use your total. Remember, percentages are part over the whole. Times 100, you'll get the amount of base that will dissolve in solution. Alright, example 3 says we have a weak acid, so that's HA. HA is going to dissolve. We have 0.425 molar concentration of acid at the beginning. Some of it is going to dissolve to form ions. And it says that 3.8 of this dissolves. So what we do is we always write our amount, and if you multiply it by the percentage in decimal form, that will tell us how much will dissolve. So I get 0.0162. And so that means that this x is going to equal 0.0162. And if x is found here, then it's going to be the same as well. And then if you subtract this from x, which is that, then you'll get the amount that remained in its molecular form right here. So calculate H plus and A minus. It's that right there. So if you guys want, you could save yourself a little bit of time and just do this. H plus is equal to A minus, which is equal to 0.0162. Maybe something's wrong with my mouse today. Alright, calculate the undissociated HA. It's right there. That's the amount that did not dissolve. Calculate OH. So you have H plus. How do you convert that into OH? You guys learned already that you could interconvert between that and that. And when you do that, you're going to plug in this number in here and OH minus. Okay, so this right here should be OH minus. That's actually my bad right there. OH minus is going to equal 6.17 times 10. So that is the hydroxide concentration. Calculate the pH and OH. So the pH, we know that H plus, what is the concentration of H plus? That will be used in this equation to give us the pH. So we plug in H plus, which is negative log, that will give us the pH, which is, okay, and then if you subtract 14 from that, that will give us the POH, which is 12. So that's one way you could do it. You could also find the POH by taking the negative log of the hydroxide concentration. You could do that as well. The hydroxide concentration, 6.17 times 10 to the negative 13, and you'll still get somewhere around 12.2. It's okay if it's off by a little bit. Shouldn't be, but. And then Ka, how do you solve for Ka? Okay, so Ka, so look at your ice table, 0.0162 squared over 0 equal to 6.44, and that would be your K. So I want you guys to try example 4, and I'm just gonna write the answers here for you.